Hello everyone again and welcome to Python tips. So today we are going to be looking at pandas. We are already done with NumPy. Pandas is used a lot, especially when you want to deal with data that is made up of rows and columns. Most of our data set that we are going to be dealing with building machine learning models are always in the form of what? A data frame, which is made up of what? Rows and columns. That's why we are treating this. And data frames are used a lot, especially in data handling as well as in data analysis. So before we can go to creating data frames, you first of all have to import pandas and alias it as PD. We already saw how to import NumPy. So I'll first of all run this. Now, we will first of all look at what is a series, what is a pandas data frame. A series is just like a row, like a column of data in a table. And why a data frame is just like a two-dimensional data structure, which it can be or a table of rows and what columns. If I want to create a series, I will first of all do, since I already imported pandas and alias it as PD, I will do pd.series. I pass in the column values that are one. It could also be strings, and then I can print. If I print this, you will see that we are having this series. If it was a data frame, let's say I want to create a data frame where I have names of persons. Remember, we already saw a dictionary where we have the name here is a key, which is going to have associated values. We have age, which is another key with associated values. So if I want to create a data frame based on this data, I'm going to just do pd.dataframe. I pass in this data, and then I'm going to run this. We will see that we have a data frame which has two columns, names and what and age. Now we can also do exploring that data frame, where if we want to just see the first two rows in that data frame, we can just put df.head, we pass in 2, and then if I want to get df.info, info here is going to give you everything about that data frame. Now we see that name is made up of what? 3 no, meaning that it's not empty objects, because we have names. Names here in form of what? Objects, which are what? Strings. Also, we have age. Age is made up of what? 3 values, which are what? They no yes, since they are not empty, and they are what? They are like integers. Now, if I do .describe here will give you basic statistics, where we are going to have the count. We have just like 3 values in age. We can get the mean, the standard deviation, the minimum value, which is like 25. Remember, when you do .describe, it is just like summary statistics. So it will only be applied to what? To age, because those are the numeric values. We cannot calculate the mean of Alice, Bob, and what? And Charlie, because they are what? Strings. Now we can also apply filtering as well as selecting columns in that data frame. If I want to just get the name column, I can just do df. I pass in like a list. I pass in that name column. And there are times we will see as we move on how to selecting multiple columns in a data frame. I can also do df.name because I know the column as name, and then I will also have the same thing. You can also do row by position, if you want to get maybe just the name Bob as well as age. So if I want just Bob, I will pass df.iLook of 1. Now, if I want to print age equals 30, I'm going to do what? iLook of df.look of what? 0. Now, there are times where you want to get maybe filter by what? Looking at the age greater than 25, where if I print this out, if I run this, getting age greater than 25, meaning that we will only end up having what? Having just ages for what? Bob and what? And Charlie. Now we can also modify data frames. Modification here means maybe we want to add another column in that data frame. Maybe we want to do some calculations in that data frame. Take for example, if I want to add country in that data frame, I can just do df. I pass in that country in form of like a string, and then I'll give it US, UK, and Canada. I can also update the values. Like if I want age updated by 1, I can just do df age, df h plus what? Dot plus 1. If I print, then also you can do like if you want to remove a column when added, if I want to drop that column called country, I'll just do df drop axis is equals to 1 and then in place true. And then if you run this, you see that at the end, we do not have that column country again. Also, we will see this a lot, what we call missing values. Missing values are just like, we have at times you collect data and there are some entries that are empty. So those are good examples of missing values. Most of the time, most machine learning models cannot handle these missing values. So there is a way either we can check, first of all, we check whether they are missing values. We can fill those missing values as well as we can what? We can drop them. So let's say I create another data frame where I have the column A. I have values like 1. np.none here means I want an empty value, like a null value, which is a none. So if I print this, like the original data frame, you will see that we have entries here with what? None, which simply means empty. Now there are ways, maybe if you want to fill those nulls with 0, you can just do df2.fill, you pass in a 0. And then if we print that, you will see that all the none values are filled with what? With 0. When we do a lot of stuff on basic statistics, we can fill these empty values maybe at times with the mean, we can fill it with the median, depending on how the data set we are working on looks like. Also, we can do aggregation. Aggregation here simply means we want to maybe do a group by and then we get the sum, or maybe we get the mean based on some groups. So let's say I have a data frame which has department, we have the sales department, another sales department, we have HR, and then with different salaries. Now, if I create this data frame, let me first of all print the data frame. Let's see, print df3. If I print this, we will have a data frame that has 2 columns. We have sales repeated here. Let's say, for example, I want to get the mean salary for each of these departments. So what you are going to do here, you are going to do your group by department, and then you want to get what? The mean salary group by what? By department. So if you do that, you are going to have now sales and what? And HR. So now you will see that if we get the mean here, we are going to have what? Grouping the mean, calculating the mean salary group by department. We are going to have a mean salary for HR to be what? 59,000. As in the case of sales, we are going to have what? 52,500. So aggregation and grouping is used a lot, especially when we are doing a lot of data analysis using Pandas data frames. So guys, keep following for more tips. Tomorrow we are going to be, looking at real world scenarios where we will go to a Kaggle, which is like a place where we can download data set and then try a lot of these, basic things we have done today. Thank you so much, guys.